In this video, let us see how to solve problems using star-delta transformation. Let us recall the formulas first to convert star to delta. So this is the star network which has a neutral point and 3 resistance will be connected to the neutral point. When you convert this into an equivalent delta, the neutral point will go off. And you have different resistance. So you have to find the resistance value. So that is given by this formula. So to find this RAB, what is this RAB? You multiply RA into RB, okay, plus RB into RC plus RC into RA divided by your finding for RAB divided by the third resistance, that is the RC. So in AB, C is missing means you divide by RC. The numerator remains the same for all the 3 formulas. Denominator alone changes and you can see whatever variable is missing here, that you have to divide it. So this is the formula. You can easily remember this formula. Just find the product, add all the products together divided by missing variable. So that will give you the delta resistance. Similarly, to convert delta to star, you have a formula. So now you know RAB, RBC and RAC. You have to find what is RA. So what is RA? You multiply, so you take the terminal A, you multiply the adjacent terminals RAB into RAC divided by sum of the resistance will give you this resistance RA. To find RB, multiply RAB into RBC divided by sum of the resistance. So any arm of a star connection is equal to product of 2 adjacent arms of delta divided by sum of the arms of delta. So remember both the formulas. Using this you can reduce any complicated network to a simple circuit. You can find the total equivalent resistance across any 2 terminals using this formula. So let us see the first problem. Determine the total resistance seen from the terminals BC by using star delta transformation. So what is the terminals here? B and C. You have to find the total resistance across this terminal. You see the problem. So here a star network is inside. Outside you have a delta network and you want to find the equivalent resistance across BC. So if you get this type of problem, always choose the central star network. Convert this star network into delta network. Your calculation will be very easy. So I have drawn this inside star network here. So you have this neutral point D here, which will be eliminated when we convert this into delta. So when I convert this star into delta, this D will go off. So I have to find the resistance value using the formula we have already studied. Now let us apply the formula and find the equivalent delta resistance RAB. That is RAB is equal to multiply all the resistance divided by the variable which is missing here, that is RC. So I am doing the calculation separately. So you multiply all the 3 values, find the sum of that. It comes around 19.2 ohms. So 19.2 divided by RC is 3.84, so that is 5 ohms. So in this one, in the delta network, we have found the value for RAB. Now let us find the other two resistance RBC and RCA in the same manner. So we have found all the three resistance which comes around 5 ohms, 12 ohms and 8 ohms. Now let us substitute this in the original network. So this is the original network. First draw the original network ABC. So ABC I have drawn it. Then mark this 5 ohms, 8 ohms and 12 ohms. Okay. Now we have found the equivalent for this star network. So we got a delta network of values 5 ohm, 8 ohm and 12 ohm. Always note the labels. Okay. If labels change, your resistance value will change. So mark the labels correctly. When two resistance are in parallel, equal resistance are in parallel, the net resistance will be half of that. So it becomes 5 by 2. Here 12 by 2 is 6 and 8 by 2 is 4. So what we have to find is the resistance across terminals BC. So BC you keep it as such. These two you can add it because they are in series. So 6 plus 2.5 is 8. How to find they are in series? If current flows, same current flow through both the resistance means it is in series. So 8.5 and 4 are now in parallel. Why they are parallel? If current comes here, it gets divided into two parts. Then it is said to be in parallel. So these two are in parallel. So you apply the formula R1 R2 divided by R1 plus R2. Find the value. So the net resistance is 2.72 ohms. So the second question is we have to find the total resistance across the terminal AB using star delta transformation. So this is a Wheatstone bridge type of problem which we will normally get in electrical engineering or circuit theory. So we are concerned about the terminals A and B because we have to find the total resistance across this. So don't alter this one A and B. You keep this lower part as such. Now this is a star network. This C is the neutral point and D also you have a star network. So you can choose either C or D for conversion. But I prefer C because all the resistance value are equal here. That will be easy for calculation. So let us take this C point. Mark C, this A, D and B. Okay, label it properly. On all the values are 1 ohms. So when all the values are equal, it is easy to convert it into delta. So this star network, if you have 1 ohms in delta network, it will get multiplied by 3 times. Okay, you can apply in the formula and verify it. Anyhow, if all the values are equal in delta, it will be 3 times greater. So it becomes 3 ohms here. You have to remember C terminal is eliminated. You have only 3 terminals A, B and D. Okay. Now let us substitute this part in this main circuit. So this is a main circuit where we are going to substitute this part. For that, first draw the lower one. A, B have kept it as such. Now you have to include this one. See, while drawing this one in this circuit, you have to remember C is eliminated. So you mark the labels accordingly. A, B is here. Between that, the resistance is 3 ohm. So between A and B, 3 ohms should be there. Between A and D, D is here. So 3 ohms, and again between BD, you have 3 ohms. In addition, we already have one 2 ohm and 1 ohm. So this also should be included. So this 2 ohm is between A and D. So A and D add 2 ohms. And this BD you have 1 ohm. So you have 1 ohm. here. Now these two are in parallel and these two are in parallel. Now let us simplify the circuit. Do this. These two are in parallel, 2 and 3. So the equivalent resistance is 1.2 ohm. And here these two are in parallel, 1 and 3 are in parallel. So you draw the equivalent one. So this can be again reduced because D can be eliminated. These two are in series, 1.2 plus 0.75 becomes 1.95. And again finally these two are in parallel. So find the equivalent resistance. So the total resistance seen from the terminals AB is this one. The third question is, a square and its diagonal are made of uniform covered wire. The resistance of each side is 1 ohm and that of each diagonal is 1.414 ohms. Determine the resistance between the two opposite corners of the square. Generally, when we see this type of question, most of the students will leave the question for choice. They think that it is difficult. Actually, it is very easy question. Okay, you just read the question clearly. It is a square and its diagonals. Okay, you know to draw a square and draw the diagonals, and all the diagonals have, it is given, it is made up of a uniform covered wire. In wire we have a resistance and the resistance of each side is 1 ohms. So in all the four sides you have 1 ohm and diagonal is 1.414 ohm. Okay. So two diagonals are there. Two diagonals you will get the resistance 1.414 ohms. Determine the resistance between the two opposite corners of the square. Take two opposite corners A and C and you have to find the resistance between these two ends. Okay. So if you read the question properly, you can do it. So let us start with this point B. So this is a star connection. Let us convert this into equivalent delta. So here you take AB, AD and AC. Okay, this is a star one. We are going to convert this star into equivalent delta. So delta, when you convert this into delta, terminal B will be eliminated. So you will get only A, C and D. Apply the formula. See, when you are going for this type of problem, you make sure of the terminals here. Okay, because B is eliminated. So when B is eliminated, you are finding RAC. Okay, so multiply 1 into 1.414, 1 into this plus 1 divided by what is missing here, AC, that missing terminal is D. So 1.414. Similarly, you apply the formula correctly and find the resistance. These two you get the same value because this resistance are equal. These 2 ohms have same resistance. So 2 ohms will have same resistance in delta also. So we got the equivalent delta. Let us substitute in the original circuit. So now we have eliminated B. Now you have A, C and D alone. So already you have between AD 1 ohm, DC 1 ohm is there and this diagonal AC is 1.414 is there. This is already there. Now you have to include this one. So what is AC? You have 2.7 ohms. So that will be in parallel. Then AD, so CD and AD who have 3.28 in parallel. Okay. Now it become a very simple circuit. These two are in parallel, these two parallel, these two are in parallel. Do the calculation. So this is 0.92, this is 0.79, and this will also be same value. Now we have to find the resistance across AC. Okay, so A and C only. So let me, across this one only you need. So these two you can add it. So you will get 1.58 if you add these two. Then these two are in parallel. So you can find the equivalent value. So the question though appears to be difficult, actually it is easy to solve using star delta transformation. So this is next problem. Here also we have to find the total resistance across the terminals X and Y using star delta transformation. You see the problem, you can clearly see that some values are same. So whenever values are same, it is easy to solve the network. Now you see here 3 ohms are in series. So you can add these two, so it becomes 6 ohms. Okay. Similarly here 2 resistance are in series, so you can add these two, so it becomes 9 ohms. So this is a delta which has equal values. Similarly this 6 ohms is also a delta having similar values. So let us convert these two delta into star connection. So the circuit will become like this: 6, 6, 6. Remaining things you keep it as such. So this is the circuit you have to reduce. Now what is the relation between star and delta? In delta, if you have R, in star connection it will be 1/3 of that delta network. Okay, so if you have 6 in delta connection, in star it becomes 6/3, that is 2 ohms. So it becomes 2 ohms and you will get a neutral point in star connection. Remaining things you keep it as such. So first I have reduced only this part. Again let us reduce this delta to star. So if you do so, you will get one more neutral point, and what will be the values? 9/3. So you will get 3. Now you see here these three resistance, that is this 2 ohm, 8 and 3 ohms. They are all in series. Here also these three are in series. Add these two. So if you add 8 plus 2 plus 3, it is 13. 2 plus 4 plus 3, it is 9. So the circuit get reduced like this, and you simplify it, you will get the answer. The question appears to be very big, but answer or the procedure is very simple. You can easily get the answer if you know the formulas. So the points to remember here are the formulas only. So remember star to delta formula as well as delta to star conversion formula. So if you like the video, do subscribe to Read Electric Vehicle channel. Thank you.